Hi everyone, my name is Agatha and I'm a part of the marketing team at MightyCon, and I would like to welcome you to our webinar on the self-drilling dowel. I'd like to draw your attention to the panel on the right-hand side of the screen. In the panel, you will find a handout section with a copy of today's slides available, the self-drilling dowel design guide, and a question section. You can use the questions throughout the presentation and we will answer any questions at the end of the presentation. Please watch for the Q&A in the follow-up email. So without any further ado, I'd like to kick things off by welcoming Dominic, one of the engineers on the technical support team at MightyCon. Dominic, over to you.
Hi everyone, welcome to the Self-Drilling Dowel webinar. So self-tapping screws have revolutionized the mass timber world, enabling bigger building and more complex structures. However, one of the governing design parameters is still the fire rating of the structure, leading to the popularity of concealed connection systems. Wouldn't it be nice for designers working in mass timber to have access to a fastener engineered for internal knife blade connections? We think so, and that's what I'll present today. So, hi, my name is Dominic Robitaille. I will be your host today. I'm a technical support engineer at MightyCon, a specialized mass timber connection system supplier. Today, we'll go over three major questions. What is the self-drilling dowel? Why use it? And how to use it. So to answer our first question, we'll go over a simple product presentation. We'll go over the self-drilling tip, the continuous thread, the concealable head, and the hardened steel. And I'll explain why these features will help you design a connection that's easier to detail and to install. What is the SDD? It's a self-drilling dowel designed to hold internal knife plate in mass timber connections that can easily be installed with a cordless drill. Here we have Max, my boss. He's installing the SDD for our installation video. And this is mostly to present that we would never sell a product that we cannot install ourselves, and we cannot expect the contractor to install something we cannot. So that's, I'll show you the video a bit later. So let's begin with our first feature, the self-drilling tip. It enables fast and simple installation and eliminates the need for pre-drill in wood, aluminum, and thin steel plate. And what we mean by thin steel plate is thinner than 1/8 of an inch. Second feature, the continuous thread that helps avoid slippage of the dowel. So once the dowel is installed, the thread is maintaining the dowel in place, and it helps to drive the dowel in. It also allows to be installed with the cordless drill because of the low installation torque. Finally, we have the concealable head designed to be used with AW40 bits. One of the most important features is the hardened steel. The whole dowel is made of the same steel, which reduces the risk of the head falling off. The hardened steel gives the dowel the high design strength, exhibiting stiff behavior. And we have a surface coating for corrosion protection on top. We can compare the bending yield strength of the fastener to a similar product on the market, and we can see that the bending yield strength of the SDD is twice the strength of similar products. So to recap this section, what is the SDD? It's a fastener designed to hold internal knife plate and timber connection that can be installed with a cordless drill because of the self-drilling tip, the continuous thread, the concealable head, and it's made of hardened steel. Next question, why use this dowel other than the high bending yield strength? Because they allow for a simple installation of concealed connection, but also because they are adaptable, they are tested, and that's what we'll explore now in this section. So to demonstrate the simplicity of the installation, I'll show you a part of our brand new installation video. So there you go. As you can see, we start by pre-drilling with a 1/4 inch drill bit. And we pre-drill all the way through to the steel plate. and then we can simply install the dowel in. You'll see there's a bit of a bump once Max hits the steel plate, but the installation is still fluid and still rapid. You can see the bump right here. Whoop. But as you can see, goes in pretty quickly still, even though we haven't pre-drilled all the way through to the other side of the CLT. And if you want a fully concealed fire-rated connection, you add a wood plug to cover your dowels once they're fully countersunk. So we'll go into a bit more detail on how the features are making for a simple installation. So first, here we have the pre-drilling. So the red part here represents the pre-drilling. So the drill tip eases the entry, and then the tread helps the forward movement. Then the tread grips onto the steel plate and guides the dowel through the steel plate. And finally, the tip finishes the drilling, and the tread maintains the dowel in place. So we can compare the simple installation of the SDD with a half-inch steel dowel. For a regular half-inch steel dowel, you'll need to use a hammer and a lot of on-site work, which leads to higher risk of splitting in the wood. On the other hand, our SDD allows for more shrinkage and swelling of the wood because they can bend a bit more. They also allow for a better stress distribution and a better load dissipation. As I mentioned earlier, if you want a fully concealed fire-rated connection, you can countersunk your dowels and cover the hole with a wood plug. So first tip for my tip section, will answer the question, should you pre-drill on-site or not? Pre-drilling off-site can seem more efficient, but it may lead to more labor-intensive on-site work, as it can be hard to align the hole in your wood member with the ones on your steel plate. So our suggestion is to use pilot holes, so you don't need to measure edge distance on your wood member on site. But once you're on site, you can use the pilot holes as guide to drill into the steel plate and then install your dowels. So our solution to should you pre-drill on site or not are pilot holes. In the following slide, I'll present visually appealing concealed connections. And to do that, we'll go over the most common framing system, and I'll show where the SDD could be used. We'll go over example in platform framing, balloon framing, and post and beam framing. So our first example looks at panel-based connection, where we have CLT hold downs and CLT-based shear connection. So the CLT hold down, we can replace the ankle bracket here with something like this, and we can replace the base shear here with something like this here, where you can see the concrete topping to conceal your steel plate completely. And this could be done in platform framing, balloon framing. And second or third example, the SDD could be used in internal splice-based connection, in platform framing again, and balloon framing. So you can have a completely concealed internal splice place connection here. Another option are internal tension straps, could be used in balloon framing. Then we have column base connection. So we have an example here of a column base, but you can do the same concept, use the same concept for column to column connection. So something here. Another option are knife plate hangers that could be used all over your structure for a post and beam framing system. And another example why these fasteners are adaptable are moment connection. Here is an example of a beam hanger where the moment is decomposed. So here you have your moment, and the steel plate on the left is going to be stressed in compression, while the one on the right is going to be stressed in tension. And if the moment is reversed, the steel plate are going to be stressed in tension instead of compression, and vice versa. So here's another example of a moment connection where the dowels are installed in a circular design to account for the moment. Our last connection is a brace connection. So on the left, we have an exposed connection from the UMass building in Amherst. And on the right, we have a similar concealed connection So if you want an alternative to an exposed connection, you can use the self-drilling dowels and have a completely concealed connection. Here on this type of connection, it's important to make sure that the dowels are installed symmetrically around the centroid of the connection. So you want your dowels to be around this part here of your connection to make sure that the load is spread properly. Okay, so another reason why you should use these dowels, because they are tested, and they are tested using CLT, and they were tested in America at the Montana State University, to be exact. So I've previously talked about fire rating. So to get the proper fire rating, you can use the same concept as for our beam hangers, which is to protect the steel with wood. As we can see in the picture here, the char layer is insulating the interior of the beam and the connectors. This picture is from our full-scale, fully loaded beam hanger test, where the connection was in the oven for an hour and a half. So even though the connection was in an inferno for a long period of time, the connectors are still intact. So conclusion, to have a fire-rated connection, you need to completely conceal your dowels and your steel plate. And as I mentioned earlier, if you want to conceal your dowels, we suggest using wood plugs, like a bit of an example here. To recap this section, why use these self-drilling dowel? Because they are adaptable, they are simple to install, they hold in place, and they are tested. Final section, how to design with these dowels. We'll go over a few important details to remember, and then we'll go over the design guide, the geometry requirements, and the bending yield strength. So first important detail, to determine the depth of your plate, you need to talk with your wood material supplier to make sure you can route a long enough slot into your plate. So on the left here, we have an example of a 23-inch blade here, and you have a CLT panel on the right. But because of how the saw is designed, you can only have a 6-inch slot into your CLT, even though you have a 23-inch blade. So that's something you need to make sure you discuss with your wood provider to make sure you can provide the right slot in your CLT panel. Another important tip, an important detail, is to make sure that you reserve extra space on the top of your connection here, because with compression, on the connection, the knife blade may act like an axe on your wood member and simply split the whole member in two. That's something you definitely want to avoid. So make sure you keep half an inch here to account for the compression on your connection. So third important detail, you need to check if your steel plate has rounded corner, like in a hot roll T-section, for example, or if it has welded corners. And in both cases, you need to make sure to bevel the corner of your wood member to make sure it fits perfectly on your steel plate. So another tip, another important detail to remember is that saw blades are round. Might sound funny, but this is a comment we often receive from installer, that the steel plate has squared corners and the slot has rounded corners. So the plate doesn't fit in the slot. So either design the plate with rounded corners, like we have here, or over design the slot to account for the curvature radius of your blade. We'll now go over the design guide. So to do that, I'll use the Canadian and the American version at the same time. And we'll use a simple column-based connection as an example. So the connection is going to use a single knife blade and 4 self-drilling dowels. Sorry, just had a little sip of water. Okay, so first step, you need to decide how many steel plate you should use. The choice will depend on the thickness of your wood member. So with the thicker member and the heavier loads, you should use a double knife blade connection. In our guide, we suggest using 1/4-inch steel plate, but aluminum plates could also be used. So for our example, we'll select a single knife blade connection. Step 2, you need to select the length of the dowel you want to use, and it will also depend on the panel thickness. So we have 9 different lengths available from 3 inches to 9 inches. And they all have the same diameter of a 1/4 inch. So here we have the graphic of the design value of the dowel here and the length of the dowel. So because of how the yield equations are calculated, the design value is going to increase with the dowel length, and then it's going to plateau. This example is for a single knife blade connection, but the concept is similar for double knife blade connection. The second knife blade creates additional shear plane, increasing the resistance of the dowel. This is why for bigger connection, you should use double steel plate connection where the plateau is a lot higher in this graph. So in our example, we decided to use a single knife blade. So let's choose a 5 1/4 inch dowel. So that would be a dowel that's about right here, right before the plateau. So that's what you always try to optimize. Step 3, evaluating the design value. But before you do that, you need to make sure that the embedment is checked. So before evaluating how strong your connection is, you need to make sure that there's enough embedment on both sides of your steel plate. So on both sides and in between as well. And this is shown in our design tables. Which leads me to another tip. Selecting the optimal spacing in a connection with 2 knife blades. To do that, you want to make sure that T1A and T1A is equal to T1B. So you want the spacing on the exterior of your connection to be the same as the spacing in between your 2 knife blades. The NDS doesn't provide clear guidance on that. Especially on double knife blades. So we use guidance from the CSA, the Canadian version of the NDS. So now let's assume that for our example, the embedment length is respected. Now we can use the design table to evaluate the design value of our dowels. So we used a 5 1/4 inch dowel. So we have 3 values here. These 3 values depend on the load direction at the shear plane. And we'll go into a bit more details. So first case here, it's parallel to the grain loading. Then we have parallel to the grain loading in CLT. And then third, we have the perpendicular to the grain loading in CLT and in timber. With the connection in CLT with 2 knife plates, it may be difficult to determine how the load is applied. So here we have an example where there could be perpendicular to grain loading on one side of the steel plate and parallel to the grain loading on the other side of the steel plate. And if such a case occurs, we suggest to use the most conservative value, so the perpendicular to grain loading, so this one here. So step 4, we need to adjust the design value. So we have two adjustment factors. In the US, we have the NF factor and the C factor, and in Canada, we have the NF factor again and the K factor. So the C and K adjustment factors are for service conditions, so dry or wet, the duration, and other. The NF factor is for the effective numbers of dowels needed. This accounts for the number of dowels, but also for the group effect. So as I mentioned, NF is the number of effective fasteners acting in a connection together, and it depends on N, the total numbers of fasteners acting in the connection. So in our example, we said we are using 4 dowels. So our effective number of dowels would be 3.6 using the 0.9 reduction factor we have here. And finally, step 5, we need to make sure that the geometry requirements are respected. So the design guide provides values for timber, glulam, and CLT. CLT here. So if you want to design a connection that's outside of the scope of our design guide with an aluminum plate, for example, or a thicker plate or really thin plates, we provide the strength and shear and the bending yield strength of the fastener. So if you want to do something else, we provided these values for you to use. So to recap this section, how to use the design, how to design with the SDD, it's by using the self-drilling dowel design guide and by making sure not to forget the important detail mentioned earlier. So that concludes this webinar. So I'll summarize each section now, and then we'll take a few questions. So if you have any questions, you can start asking them right now, and we'll go over them at the end of the presentation. Okay, so I'll go over my questions first. First question, what is the SDD Self-Drilling Dowel? It's a fastener designed to hold internal knife plate in timber connection, featuring a self-drilling tip, a continuous thread, a concealable head, and hardened steel. Remember the really high bending yield strength. And then question 2, why use these self-drilling dowels? Because they're adaptable, they're simple to install, they hold in place, and they are tested. Question number 3, how to design with the SDD? By using our self-drilling dowel design guide that we provide for Canada and for the US, and by making sure not to forget the important details I mentioned in this presentation. This webinar is going to be available on our website, and we'll also send an email, a follow-up email with the presentation, the slides, and the questions and answer. Well, we'll answer all the questions, and we'll send you answers to all of your questions. And we'll also have the installation video for free on our website. And in HD as well, because in this presentation, the version was kind of not perfectly HD because we have to stream and everything, but yeah, we have a really high quality version on the website. Okay, so thank you for attending. And now I'll start reading and going over a few questions. So while we wait, and I'll just close this here. So yeah, while we wait for the question, I would like to mention that we'll be at the Portland Mass Timber Conference in March. So come say hello. We'll have a few new prototypes to present, and we'll also have a few new documents to present. So questions. So I have a first question here. What type of failure mode did you see in the testing campaign? So for the single knife blade connection, the single knife blade connection created a really nice yielding, so really what we expected. The double knife blade connection created something with a bit less deformation than we expected, but still the testing was positive and really, but what we expected, just a bit less deformation, but still pretty good. Okay, I have another question. Do you have to pre-drill all the way through? No, you don't have to pre-drill all the way through. What we suggest is pre-drilling at least through your steel plate if it's thicker than 1/8 of an inch. That's going to really ease the entry. But if you don't want to pre-drill, you don't have to if you're respecting the requirements. But the installation is going to be a lot more labor intensive once you're on site. Okay, another question we have. Can we use these dowels in wet service condition? Sadly, no. These are designed to be used in a dry service condition. So if you want to design in wet service condition, we would suggest using something else. And here at MightyCon, we provide stainless steel screws for those type of connections. So you can contact us for any question, by the way, on our email. So support@mightycon.com or on our website. So if you have any question, you can contact us there. So I'll just finish the presentation by leaving you with Agata. But like I said, we'll send a follow-through email with all the questions answered and all other information you might need about this presentation. So thank you very much. And there you go, Agata.
Thank you again for joining us today. As a reminder, you will receive an email on Monday with a recording of the session, slides, Q&A, as well as a survey where you can get your certificate of attendance. If you have any further questions, you can contact us at info@mightycon.com or support@mightycon.com.